Welcome, independent researchers, skeptics, and all of humankind, to Shadow Citizen. Shadow Citizen will explore the shadows of an alternate reality. Your hosts, Rachael L. McIntosh.
All right, here we are again, everybody. I'm Rachael McIntosh, host of Shadow Citizen, and tonight I'm really excited. We have a guest that I'm just astounded he's on this show with me. His name's Ken Caldeira, and in the 1980s, Ken held a number of positions developing computer software for clients in New York's financial district, and now he's famous for his world-renowned modeling on global carbon scale, marine biochemistry, and chemical oceanography, including ocean acidification and long-term evolution of climate and geochemical cycles. Most recently, he's recognized for his climate intervention proposals and energy technology. You may recognize his name because he was the lead author of the UN's Intergovernmental Panel on Climate Change, IPCC AR5 report, and was the coordinating lead author of the Oceans chapter of the 2005 IPCC report on carbon capture and storage. And I'd really like to have him come on the show right now. Ken, are you here?
I am indeed. Nice to be here.
I'm so happy you're here. Thank you so much for showing up for this. And I was just calling the hotel to see if you were there, and when I called, they patched me through to your room, and we ended up talking to each other, and I was so happy about that, and you agreed to do this show, so thank you very much for doing that.
Well, thank you.
Now, I saw that you had released a paper 2 days ago, I think, called The Simultaneous Stabilization of Global Temperature and Precipitation Through Cocktail Engineering. What is this cocktail engineering? It sounds fascinating. Tell us about that.
Yeah, well, maybe we could start back a little further with just the whole sort of global warming. And
yes,
I actually
go
got
ahead.
involved. I first heard, this will sort of show my age, but I first heard about global warming in 1979 when there was an article in the New York Times about how Antarctica might be melting as a result of our greenhouse gas emissions. And the most important greenhouse gas is carbon dioxide coming from burning of fossil fuels like coal, oil, and gas. And so at that time, I had just graduated college and was working, just doing computer programming and other things in the financial district. And anyway, so I eventually went back to graduate school because I wanted to do something about this problem. I thought I should learn about it. And I went to an unusual program at New York University that was combining energy system analysis with climate analysis, which was really at the forefront. And that was because it's a remnant of, in the 1970s, Jimmy Carter had a clean energy research program that came with these oil shocks and so on. And so I came out of a educational program that looked at integrating both sort of solutions with understanding the science of the problem. And most of my time these days is spent really some on climate science, but probably more on thinking about energy system transitions and how do we stop making things with smokestacks and tailpipes. But just in the same way that if a patient has cancer, you try to solve the underlying disease, but you also want to provide symptomatic relief and maybe give some painkillers and so on, that there's a similar thing with the climate system. Solving the disease means transforming our energy system so we don't have smokestacks and tailpipes and cutting down forests and so on. But, there might be potential to provide some symptomatic relief, and this is very controversial. But, if you look at, I'm sorry if I'm babbling on too much.
No, go right ahead. People are hinged to your every word.
That if you look at projections for later this century, the tropics get extremely hot. And the potential for widespread crop failures is large. And so there's at least some potential that there would be widespread famines through the tropics. Now, I think if actually the rich countries came to the aid of the poor countries, that there's probably no reason for anybody really to go hungry, but there's no reason for anybody to go hungry today, and there are plenty of people going hungry. And so, anyway, to back up a little bit, in 1974, a Russian climate scientist named Mikhail Budiko wrote a book, and he noticed that big volcanoes cool the planet. And so, for example, in 1991, there was a big volcano in the Philippines, and the next year, the planet got more or less a degree Fahrenheit cooler despite rising greenhouse gases. And it's thought that this big volcano put tiny particles in the stratosphere, the upper atmosphere, and these little particles reflected sunlight back to space. And since the sun is what really warms up the Earth, that reflecting some of that sunlight would cool it back down. And from that volcano and other volcanoes, people understood that, well, we could do the same thing and put little particles in the stratosphere and reflect the sunlight. And it turns out it looks like it would be really easy to do and be quite effective at cooling the Earth. But one of the things that happened after that 1991 volcano was the next year, the Amazon River had its lowest flow ever, and also the Ganges-Brahmaputra over in India and Bangladesh had the lowest flow ever. And it turns out that if you sort of heat up the planet with carbon dioxide and then reflect some sunlight away, you cool back the planet, down the planet, but you make it drier. And so, not to get into too much detail, but there's very high clouds called cirrus clouds. These are these little wispy clouds that you see on some days that are really high up. And those clouds have a warming influence on climate. And people have suggested that there could be engineering approaches to getting rid of those, or at least to reduce the amount of those high clouds. I'm not saying whether it would be wise to do it or not. And that method would also possibly cool down the Earth, but if it worked, it would actually leave the planet rainier than it would otherwise be. And so we had this sort of idea, well, if one approach dries out the planet too much and the other one leaves the planet too rainy, maybe if you mix the two together, you could restore both temperature and the amount of rainfall. And the conclusion was kind of mixed, and the answer was, well, yeah, you could do that on a sort of over the whole globe or over all land, but it didn't work regionally. So even though you sort of could bring back the average regional precipitation, average sort of global precipitation, that you still were left with big regional mismatches, with some places getting wetter and some places getting drier. But anyway, it's more of a theoretical study. But just to say that people are thinking about these kinds of geoengineering or climate intervention approaches, but everybody working on it understands that it's just symptomatic relief and doesn't address the fundamental problems.
Yeah, you mentioned you made your analogy of cancer. Do you really feel that in your heart that what's going on the planet right now is a cancer? Is it something that's going to kill us if we don't do something?
There's scientists with a wide range of different views about how bad climate change will be. And I think that, one of the things I study is ocean acidification and the effect of our carbon dioxide emissions on corals. And I think, we're already seeing coral reefs bleaching throughout the world. And, I think most coral scientists now believe that within a few decades, if we continue current patterns of emissions, that, well, there might be a few reefs hanging on, they won't be sustainable, and there'll basically be no sustainable reefs left on the planet. And I think the coral reefs are the things that are getting hit by climate change and ocean acidification first. And, the question was, well, is the coral reef just like the canary in the coal mine, and are there, is the rest of the biosphere sort of marching behind them? Or is it really that that's the main thing we need to worry about? We did another set of simulations looking at what would happen to Antarctica if we continue burning our fossil fuels. Now, Antarctica will take thousands of years to melt, but if we continue burning fossil fuels, eventually it will all melt, leading to something like 200 feet of sea level rise over many thousands of years. But the rates of sea level rise, maybe not this century, will be sort of on the order of like an inch a year or a foot a decade, which is a pretty healthy, I don't know if healthy is the right word, but a pretty rapid rate of sea level rise. But,
yeah, considering I live right on the water, right here in Rhode Island, so that would be a big, big deal, yes.
Yeah, so, if you have a foot, an inch a year, that's a pretty, that's enough. Anyway, that's a pretty healthy rate of rise. Let me just say a third study we're working on, which this one's not published, is something we're working on now, is looking at, if you look at where people live today and how that relates to climate variables and what kind of weather conditions people like living in. And then you say, okay, under a climate change world, how many people might be motivated to migrate as a result of climate change. And what we found, people talk a lot about people from Sahel, from West Africa, where many people have subsistence agriculture and it's getting drier and it's harder for people to feed themselves. And that would likely be an area from which many migrants would come. But most of India is already very hot and humid. And if it gets much hotter, there could be, a huge number of people motivated to migrate. And so globally, we could be talking, on the order of billions of people who would be motivated to migrate. And we've seen with, what's going on in Europe with the Syrian refugees and so on, how,
right.
How a relatively small number of migrants can create big dislocations. And so, there was I think that, some people think that, well, climate change is going to be kind of a nuisance and a cost, but we'll muddle through and deal with it. Other people think that, well, it's going to be, catastrophic and an existential threat to modern civilization. And I guess my view, and some of my colleagues think I'm a little too sanguine about it, but that I think the rich people who live in gated communities might do fairly well under climate change. But if you're a Bangladeshi living on the floodplain, or if you're on a small island nation that's going to get flooded, or if you're a subsistence farmer and you can no longer grow the food to feed your family, for those people, it's going to be an existential challenge. And so one of the questions is, does that existential challenge to disenfranchised people, does that sort of balloon up and become an existential challenge for everybody else? Or, are the rich people living in gated communities going to be able to, get better guard dogs and maintain their gated communities? But anyway, it's not a utopian vision of the world either way. Just to keep babbling, sorry for babbling.
It's okay. It's more than okay. I wanted to ask you, though, back to this, the cocktail engineering, because I did read the abstract for it online. And I don't, I'm no expert on this. And I just wanted to ask, what exactly is a sulfate injection? And what exactly is the cirrus cloud thinning, which you sort of touched upon? And is this all called forcing? Because I noticed the word forcing used.
Yeah, well, climate scientists use the word forcing to refer to anything that humans do, or it could be nature even, but anything done to change the state of the climate system. And so so if we add CO2, let's say we were to double the amount of CO2 in the atmosphere, that would prevent on average 4 watts per square meter of energy escaping to space. And so we would say, the forcing is 4 watts per square meter. And so basically the forcing is how much energy does some change prevent from escaping to space. And so cirrus clouds, those high wispy clouds, I spoke about, that if you removed all those clouds, around 6 watts per square meter more of energy would escape to space. So we say, the radiative forcing from cirrus clouds is around 6 watts per square meter. So it's just a term for how much energy is some process or feature keeping, in the Earth system and preventing from escaping to space. And so this idea of stratospheric aerosol injection or sulfate aerosol injection is this is the idea that was first proposed by Russian climatologist named Mikhail Budiko in the 1970s. And he noticed that after big volcanoes, the planet cooled off.
Right.
And so he basically had this idea of doing what big volcanoes do and putting aerosol particles in the stratosphere. And so this is now known under different names, but sulfate or stratospheric aerosol injection is one of those. And then more recently, so since that time, people have thought other ways to tinker with the climate system. And, and I would just say that all this is going on inside of models and not the real world. And
good. I was just going to ask, are we all on a computer, or are we doing this like flying around and how's it? Tell me about this.
It's all going on inside of computers, but people do want to do outdoor experiments, of which hasn't really happened yet. And so, and this is obviously controversial, and maybe we can get into this later. But just to go through the other idea of seeding cirrus clouds, and I don't really fully understand the mechanisms by which it would work, but again, there's some idea would be to do some cloud seeding to make the particles in the cirrus clouds bigger so they would fall out faster. Okay. But yeah, I mean, I would say, everybody should have concern. I mean, the problem is we're tinkering with the climate system by releasing carbon dioxide and methane and a bunch of other things. And the idea that we're going to fix things up by tinkering more with the climate system, typically when we interfere in complex systems, we tend to screw things up and not make it better. And so the idea that these approaches would actually help, I mean, I think they might help, but I think things would need to get in a pretty bad state before we want to take the risk.
Okay. All right. So I know that every day there's 6 million gallons of jet fuel used. What sort of volume would we be talking about when you're doing these on the computer? It's all theoretical at this point. What sort of volume would you be injecting into the atmosphere if we're using 6 million gallons of jet fuel to get flying around every day? What do we talk about volume for this type of?
So I think each year you would need to put up an amount of material that, if you thought of a giant cube where the length of each side of the cube might be the length of a football field, that's about the amount of material that you would need to put up each year. And the amount of, if you did it with airplanes, the number of plane flights would be equivalent to a few percent of current commercial aviation. So basically you're talking about a couple of percent increase in the number of flights. And it's thought that, nobody knows the exact amount of money that it would cost, but, something on the order of $10 billion or tens of billions of dollars, which is a lot of money, but converting our energy system is on the order of trillions of dollars. So, you're talking about an effort that's like 1% as big as the effort we would need to transform our energy system.
Are we going to end up doing both, though? Or do you think we're just going to focus on the climate stuff and still continue what we're doing? Or are we going to end up doing both anyway?
I think, while we are building some wind turbines and solar farms and so on, the percentage of energy that's coming from fossil fuels today is almost the same as what was coming from fossil fuels 10 or 20 years ago. And the rate at which we're converting our energy system is at least a factor of 10, and probably much more than a factor of 10 too slow to really properly deal with the climate problem. And one of the problems is that humans, just our psychology, we're not that good at investing in avoiding bad outcomes, but once something bad happens, we're willing to do a lot. And so, one scenario is that we basically continue doing almost nothing about climate change until there's something catastrophic. And then, maybe we start deploying these, we meaning society starts deploying these symptomatic relief efforts and then gets serious about transforming the energy system. But we're certainly not serious enough about energy system transformation right now.
Now, the combination of the sulfite injection and the cirrus cloud thinning, how does that compare with the University of Washington's plan to spray seawater from Monterey Bay directly into the mesosphere? My understanding is that the salt water would cast a big shadow and it would help cool the planet. Is that potentially safer?
There's the idea you're referring to is called marine cloud brightening, and there's certain areas of the ocean where the air is super clean. And if you look up at a cloud that's about to rain, it's this big gray, rain clouds typically look kind of gray, and that's because the droplets are, and they're gray because the droplets are big. And if you look at a white fluffy cloud, those white fluffy clouds have droplets that are small. And if you've ever seen like either salt with very big crystals or rock candy, that when it's big crystals, it looks kind of gray. But if you were to take a mortar and pestle and grind up the sugar or salt to a fine powder, the fine powder would look white. And it's the same basic idea of clouds, that when clouds are little fine particles, they're white. When they're big droplets ready to rain out, they're gray. And so the idea is to take gray clouds and turn them into whiter, brighter clouds that would reflect more sunlight. And their idea on how to do this is by making a fine spray of seawater, and then the salt in the seawater would act as nuclei to allow a bunch of very tiny cloud droplets to form. And it's similar to cirrus cloud seeding. It's unclear whether this would work and at what scale. But I think if it does work, it's something that could be potentially done regionally. So maybe you could do it off the coast of Los Angeles and try to cool the desert Southwest, and might be more acceptable. But it's not been tested outdoors, although there are some people at University of Washington and other places who are trying to get an outdoor test going, but that hasn't happened yet. The basic feeling is that the stratospheric aerosol approach, because it's more or less doing what volcanoes do, and we've seen volcanoes cool the planet, we pretty much know that one will work. And whereas this cirrus cloud thinning and the marine cloud brightening, maybe it'll work, maybe it won't work. And also the maximum, even if they do work, they might be able to address some fraction of the warming from our greenhouse gases, but probably wouldn't be able to offset it all. And so this is why this idea, though, of cocktail geoengineering or using different approaches simultaneously, so that maybe, well, one approach isn't perfect, but by maybe mixing a few approaches that you'll come up with something better. But it's pretty much at a fairly speculative stage. And, I think if there was massive catastrophe next year and the poor countries of the world said we need to cool things off rapidly, that the stratospheric aerosols would be what people would do. I should point out that even if we stopped all of our greenhouse gas emissions instantaneously the world over, that the world would stay warm for many centuries, if not thousands of years. And because the greenhouse gases, especially carbon dioxide, last in the atmosphere a long time. And so really these climate intervention approaches are the only ways known to actually cool the Earth off within our lifetimes substantially, or within a political relevant time scale. And so if there really are massive famines due to heat stress or droughts caused by global warming, and people demand that politicians do something, that transforming our energy system, while it's essential to do, isn't going to cool things off. They'll just prevent things from getting as warm as they would be otherwise. Mm-hmm. And if you actually need to cool things off, at this stage, these geoengineering approaches are really the only known ways to cool things off within a few years.
Okay. So the plant, the spraying of the seawater isn't scalable enough to deal with the catastrophic event you're envisioning happening.
It might. Well, first of all, since there's nobody knows whether it would really work. I mean, this idea of the marine cloud brightening, people have seen behind ships at sea. If you look at satellite photos of the Earth, that in certain areas you can see ship tracks that look almost like a contrail from behind an airplane. Mm-hmm. And these ship tracks are because the ship's smokestack is putting out all kinds of dirty sulfur and other compounds, and so these white tracks through some parts of the ocean from the ships is reflecting more sunlight to space. So people sort of think, oh, this should work because we see ships doing this, but what the ship's putting out is sort of dirty city stuff, and you could pretty much get the same effect just by spraying seawater in the sky, which seems a lot more benign. But there are details that I don't want to get into technical here, but clouds tend to be updrafts, and maybe you're creating, right where there's this updraft, you create a cloud, but maybe it's darker next to it where the air is coming back down, and are you really cooling things off? And so, I mean, it probably works, but probably is limited, and nobody really knows because nobody's ever gone out and really tried to do it.
Mm. So, all right, so nobody's gone out and done this before. This is all theoretical, as far as you know, what you're talking about.
Yeah, this is all in. There was I think the Russians did some little demonstration of something, but, all the kind of stuff that I'm talking about here is done in climate models.
Mm-hmm, mm-hmm. Okay. Now, what you're thinking about, which is your climate models, if it was to happen in real life, what is the level of forcing? You told us what forcing meant. What is the level of forcing you might expect? Would it be minor like a volcano, or would it be like Pintabo or Timraba event from 70,000 years ago?
Yeah, so you're sort of attempting to pronounce several major volcanoes. So the biggest volcano of the last century was Mount Pinatubo, and then was Tambora. So the Mount Pinatubo, that first of all, it put a bunch of material into the stratosphere, the upper atmosphere, and that material fell out of the atmosphere mostly after a year or two.
Mm-hmm.
If that amount of material were replenished and kept in the stratosphere, that would be enough. Or the other way of thinking it is if we ramped up to that amount of material in the stratosphere over the course of this century, that would be enough to offset more or less all of the warming expected this century. So that what we experienced in 1991 and 92 was more or less equivalent to a full-scale deployment of solar geoengineering scheme. But since the atmospheric greenhouse gas concentration is increasing, if we continued a business as usual scenario, which I hope we won't do, and we put in sort of 1% of Mount Pinatubo this year and 2% of it next year and 3% of the next year and sort of slowly ramped up to full scale, that would more or less prevent all of the warming expected for this century, which, and the issue is that it's actually relatively easy to do, and one of the fears of people is that people will think, oh, well, there's this easy techno fix that's relatively cheap and small numbers of people can do on their own, versus transforming the whole global energy system, which, requires lots of effort by many people. And I think really this framing as an either or is a false dichotomy because, I think everybody agrees that if you don't transform the energy system and you keep building up greenhouse gases in the atmosphere and then you keep building up the amount of particles in the stratosphere to try to offset that sooner or later that's going to lead to a bad outcome. That's sort of like thinking, I don't know, you're going back to the cancer metaphor that it's, I can still smoke cigarettes and et cetera because, if I get cancer, I can always have morphine to make it not so painful. That's just not a way we want to conduct our lives, I don't think.
Right. So you said something earlier. You mentioned one of the models you're looking at is injecting more CO2 into the atmosphere. And so that's, that to me, I'm just a normal person. That to me is supposed to be like a greenhouse gas, correct?
Yeah, maybe I misspoke, but we've done plenty of simulations injecting different amounts of CO2, but yeah, CO2 is a greenhouse gas that leads the planet to get warmer and acidifies the ocean and does a bunch of other nasty stuff. So, although plants on land like CO2, and most of the carbon in trees and plants comes from the atmosphere, and so, but for just about everything else, carbon dioxide is not a good thing.
Okay. So you wouldn't be squirting more CO2?
In models we do it, but I spend most of my time trying to get people to squirt less CO2 into the atmosphere in the real world. So.
Okay. All right, good. Now, here's my question. You said when the government, it's politically prudent to get involved with the environment like this. When do normal citizens, the normal people, get to know what's being proposed, and how will they be alerted that this is going to happen, or that they have any sort of say in what's going to happen?
Yeah, so this is a big and complicated area, and an area of active discussion by many people. One can say about what ought to be and then what might be, and those might not be the same things. So, I think most people would think inclusive democratic systems that, have input from relevant stakeholders and so on is what you want. Now, in the real world, governments are often not particularly responsive to the needs of the citizens, and how do you actually get consultative, consensual decisions made on controversial things is not straightforward. There are people, like there's something called the International Risk Governance Council, who have previously worked on mostly nuclear weapons issues, and they've turned their attention to this question about how do we manage risk in this area and international cooperation. There are also people who are social scientists thinking about governance structures and environmental treaties, thinking about how these decisions should be made. Now, I'm a physical scientist and not an expert on governance, but one of the things we do see in the real world is that not everybody follows international law, and so the United States, along with this coalition of the willing, invaded Iraq even while the UN was still doing its processes looking for the weapons of mass destruction, or Russia recently took Crimea in contravention to international law. And so, big, powerful countries do things that they perceive to be in their national interest, regardless of whatever governance mechanisms might be in place. And so, I think if push comes to shove and things get really bad, governments can just ignore international law. Now, but I think governments won't want to do this. I think because whoever starts toying with the climate system, if somebody gets a major hurricane or drought or whatever, they're going to blame whoever's tinkering with the climate system. And so I think powerful countries are going to want other countries to do it. But you can imagine if Ghana and Sub-Saharan Africa or broader regions of Sub-Saharan Africa are undergoing drought and famines, that if the United States or China or Russia or one of the other big powers really wanted to deploy a system, you could imagine them saying wink, wink, nod, nod, and getting poorer countries to do it as their surrogates. Or anyway, you could imagine different scenarios.
Climate change via proxy. We do a lot of stuff via proxy.
Yeah, well,
sure.
Just because I think nobody wants to get I don't think anybody's. You could just imagine that some countries started doing solar geoengineering the year before Hurricane Sandy hit New York or Katrina hit New Orleans. That the natural thing would be to blame whoever is tinkering with the climate system, and so I don't think. So I think lots of countries might end up wanting some other country to do it, but I have a feeling that nobody really wants to take the blame and responsibility for it. I mean, the best thing, of course, would be, the United Nations is not a perfect institution, but some kind of body that would be more representative and more inclusive and make a well-informed decision consensually would be the ideal. But I have a feeling, just given how the world works, eventually somebody who's powerful enough who wants to do it might just do it.
Is it possible that somebody was testing or doing experiments with the weather around the time of Hurricane Sandy?
No, because in order to do these things, you need a fleet of airplanes, and you need to be putting out all kinds of aerosols, and scientists would, it would be observable both through normal military intelligence channels and also scientific observations of aerosols and so on. So it can be ruled out that anybody's doing this already.
All right. So if what you talked about, getting the levels of however we want to do this aerosol injection, getting up to that Tambora level, and you said in your one of these plans that you were hypothetically talking about, you do it like you stagger it instead of just dumping out all at once, a Tambora type of event.
I'd like it to be as continuous as possible and spread out. And, people are starting to do simulations looking at specifics of how you might deploy it. But basically, you'd like to produce some kind of even layer of particles and, avoid kind of clumpiness in it. And so you'd like to probably have a bunch of airplanes and spread it out pretty widely.
Mm-hmm. And ideally, you'd like everybody on the planet to be in agreement on this so that the whole planet is kind of moving in the same direction weather-wise. You don't have these
although,
patches.
there are, I think if huge fractions of the world are starving, that's not going to be good for the economy of the world. And so, I think that if it really starts seeming like climate change is bad, really bad for the planet, that there might be some fairly broad consensus to do something quickly. But while you'd like everybody to participate in every decision, every day we're subject to this, other people make decisions that affect our lives that we get no input on, and
right.
But of course that's not good. But eventually, unfortunately, power systems come into play, and people who are powerful enough to make decisions and execute those decisions do so. And in the real world, not everybody gets to participate in every decision. I noticed our government recently has been making a bunch of decisions that they haven't consulted with me very much. So.
Yeah, good point. All right. So, now when us, just hanging out on the planet, the inhabitants of the Earth just happen to be underneath one of these dispersals of what exactly would be dispersed on us during one of these?
There's different ideas of what to disperse, but what the volcanoes did was sulfur dioxide, that's sort of SO2. So it's like CO2, except it's a sulfur molecule instead of a carbon molecule. And then that gas, that's actually released as a gas, and some of that gas makes it up into the stratosphere where it oxidizes into a sulfate particle. And actually, when it's surrounded by water, it really becomes intense sulfuric acid. And so it sounds pretty nasty, and it is pretty nasty. But that's what the volcano did. And so so one of the proposals is to either put up this SO2 gas, or there's other hydrogen sulfide or sulfuric acid. But there's other ideas for other particles, and the engineering of it would be a little more difficult, but would probably be better for stratospheric chemistry. So, for example, David Keith has proposed putting up tiny particles of calcium carbonate, which is the material that coral reefs or seashells are made out of, or even there's little nanodiamonds, little micro bits of carbon. And these things would probably be better for Earth's climate system and the atmosphere than sulfur. But there's been more attention to sulfur just because that's technically easy to do, and that's what volcanoes have done. But almost any little particle of the right size would do the job. Okay.
All right. So the choice between sulfuric acid and calcium carbonate, I'd likely want calcium carbonate myself because I don't know. Because it sounds a little more palatable. I mean, I brush my teeth with baking soda, for goodness sake. So,
and also that calcium, just like a little side effect that might be concerned that putting sulfur in the stratosphere damages the ozone layer, and the ozone layer helps protect life on this planet.
Yeah.
And calcium carbonate has the opposite effect of helping restore the ozone layer. And so, there's plenty of reasons why you maybe would like to use something like calcium carbonate. The thing with the sulfur is you can emit it as a gas, and then it disperses and then oxidizes to form particles of the right size, whereas to actually disperse the calcium carbonate and prevent it from clumping and all this is more challenging.
Mm-hmm.
But, people are starting to think about how you might do that.
Yeah. Now, as you know, I'm on this show, Shadow Citizen, on American Freedom Radio, and I'm bumping into all sorts of people that have got all different opinions about geoengineering. And I just want to ask you something, and I want your real opinion about this.
Okay.
This is what some of the things that people have been sending to me. And here's my question too. Why does aluminum have to keep showing up in these geoengineering things? Like, what does aluminum do to make geoengineering work?
So, I would say the people who talk about aluminum, there's some conspiracy theorists out there known as chemtrailers who talk about aluminum a bunch. But, aluminum has been mentioned. Almost any particle that's small enough will have a similar radiative effect. Because basically you just want little particles that will scatter sunlight back to space but that will let Earth's heat go out to space, and so their little particles will do that. And alumina particles were, another thing that could do it, but I don't think it's not been a focus of much research.
Okay, because, I think I've seen these studies, they look very legitimate, that the healthy effects of aluminum are not very good. You get problems like neurological problems like Alzheimer's and dementia, and they're not good for crops. And then on top of it, Monsanto has developed a seed for aluminum resistance. And I don't know, so they must have known that this was going to be coming at some point. So can you comment on that?
Aluminum is one of the most common minerals in Earth's crust. That Australia, to a large extent, is a giant block of aluminum, and that if you reach into pick up almost not any rock, but many rocks, it will contain a bunch of aluminum, and so it's not just this element being present. It's not so much an issue as to, but what form it's in. And is it, bioactive or what? But I'm not an expert in this, but I'm just saying that the focus has been mostly on sulfur, and then people have been thinking a bit about other particles like calcium carbonate. And, I think people have looked at aluminum just in terms of sweeping through what are the sort of radiative properties of different compounds, but it's not a focus. I'm at a meeting right now, and I think I heard the word aluminum once.
Okay.
Nobody's proposing really putting aluminum.
Oh, good. That's good. How does aluminum then get in the rainwater? Because here in Rhode Island, where I live, there is a bill that's being passed around, an anti-geoengineering bill. Basically, they're trying to license people that are taking off in airplanes and spraying chemicals so that your wedding day doesn't get rained on. And, it's one of those things. I think it's a way for the state to make some money, but, I think it's also a way to try to curb the practice of geoengineering in general. And, I had my water tested when I heard about this whole bill, because I didn't even know what the heck this thing was about. So I had my rainwater tested, and it did in fact have sulfur in it. It had aluminum in it. It had barium in it. And it had something else in it. And I was like, how did this even get here?
Yeah, well, it's probably the mineral dust for the most part.
Okay.
So let's separate a few things. There is cloud seeding, and that's often used as silver iodide and chemicals like that. And so in California, they've been seeding clouds for the last half century to try to get more snow on the mountains. I think mostly for having more water in the reservoir. But there's a set of conspiracy theorists who believe that your normal contrails behind jet airplanes are part of some nefarious secret spraying program, and it's hard to, there are also people who think the Earth is flat, or who think the CIA was behind the destruction of the World Trade Center, or said the CIA killed John Kennedy, and that these people are true believers and, are hard, that I don't think they will change their views in the face of facts. And so we did a study where, I'm not an aerosol expert or a contrail expert, and so we did a study where we went to 72 experts and asked them, like, would you have seen, if there was such a secret spraying program, would you have seen evidence of it? And basically, and basically one of the people said that they once had a sample that they couldn't explain that had barium and aluminum and so on in it they couldn't explain, but nobody thought there was strong evidence for any kind of secret spraying program. And just imagine, I just don't see how you could ever keep something so big secret. It just doesn't seem plausible. And also, the things that you would see, you would just, people are studying. I talked to somebody who's an aerosol person and said, would you have see evidence if they were really doing this? And they said, yeah. And that, once they measured some sample somewhere and they couldn't figure out what was going on with it, and it turned out a couple of blocks away there was a dry cleaner, and the dry cleaner was putting out chemicals that showed up. And so I think these things, many of them are just ordinary natural background. Some are industrial, but none of them are indicative of any kind of secret nefarious plot.
Right. How long does it take for something like the sulfur that was in my rainwater to be up in space or the atmosphere, and how long does it take to come down as rain?
Well,
could it be yesterday, or could it be?
Yeah, well, sulfur, there's, if it's in the lower atmosphere, it was probably there for a few days. Things that are in the lower atmosphere typically rain out within a week or so, 5 days or a week.
Okay, that's good
Things
information.
that are in the stratosphere takes a year or two. So basically down here, rain cleans out the atmosphere pretty fast. But, let's say how could, sulfur, there's a lot of sulfur in seawater. There are sulfur compounds coming off from plankton, and, there's...
good point, because I do live right here next to the water, next to the ocean.
So that could have been sulfur that came from, from plankton in the seawater that gets rained down on you. It's not, anyway.
Yeah, no, I appreciate taking the time, because how long has this been floating around? You gave me some good answers there. A couple days if it was just low level, or if it was up high, it was like a year.
I'm actually just guessing too. I have to say I'm not an expert on that, but I know that.
No, but that was good because you made me feel better. But
so I know that rainwater, when water evaporates, it takes typically 5 days or a week for it to rain back out, and so that's a kind of characteristic time scale for sweeping things out of the lower atmosphere.
Now, here's another thing. I heard that when physicists gauged their knowledge of the universe, it was some study they did, they missed 97% of it. And I watched global warming sort of pause right after getting really terrified about reports about global warming in the 90s. And now it seems we're certain that we know what we're doing, and not talking about modeling, but actually going out and doing it. and now we're going to put more pollution, more CO2 or more sulfuric acid in the air. And that's tough for a lot of people to swallow. I'm going to hope you come back after the break and answer some more questions with me. I hope.